Okay, in this case we're looking at factoring twice. This, I notice, is a difference, because there's a minus sign, I checked that off, of perfect squares. This is x squared times x squared, and this is y squared times y squared. Okay, so according to our factoring of different squareds, I can write this first circle here, the second thing in a circle here, and do that twice. And then I put down opposite signs. So I'll put a plus here and a minus there. Opposite signs. Now, always check every bracket. This guy has a plus sign between two perfect squares. He cannot be broken up any farther. So he stays the way he is. However, this thing has a perfect square there, whose square root is x, a perfect square there, whose square root is y, and a minus sign. So she can be broken up. An x and a y in the first bracket, an x and a y in the second bracket, so whatever's in those circles goes in the bracket, and then opposite signs. So in factoring twice, you're always looking for any bracket to see whether it can be broken up into two brackets. Now this one fits the same pattern here. Okay, I am looking for something that can factor. And what multiplies to make 36 and adds up to 13? This is just a simple trinomial because there's no number in front. So if I look at things that multiply to make 36, I get 2 times 18, 3 times 6, 4 times 9, and these are the guys that add up to 13. Okay, both signs are the same and they're both equal to that. Okay, so I would put down a 4 and a 9, and both signs have to be negative in order to give me negative 13. Now the only difference here is how did I get y to the fourth? That must have come from y squared and y squared. And how did I get x to the fourth? That must have come from x squared and x squared. Okay, now let's factor again. This is a perfect square whose square root is x. That's a perfect square whose square root is 2y, and that's a minus sign. This is a perfect square whose square root is x. This is a perfect square whose square root is 3y, and that's a minus sign. So both of these brackets can be broken up into two more brackets. This must have come from x and 2y, x and 2y, with opposite signs. And this baby must have come from x and 3y, x and 3y, with opposite signs. And again, it doesn't matter which order you put in the opposite signs. So the whole thing breaks up into 4 brackets. Okay, so again we come right back to our original concept, is whenever you are breaking something up, look at each bracket to see whether the brackets can be broken up farther. So this is an example of factoring twice.